All right, welcome back. We're going to try to solve this problem. We did one similar to this in class, but it was a pretty challenging problem. It had a lot of components to it, so I thought we'd go through it with a video so you could see in case you saw me in class doing something like this and you didn't take notes or you didn't take good notes or you were looking at your notes and you couldn't figure them out. So let's take a look here. So what I've got is I've got my function. I'm trying to find the smallest x value that I can put in here and make sine equal -1. So what I really want then, what I'm really looking for is, when I do this, I want sine of something to equal -1. Now that thing we could call any angle. In class we called it theta. So for now, if we call that theta here, this theta will temporarily represent x squared plus 3x plus 3. So what I want to do is kind of think about what are these possible values of theta. So the things that could make sine equal to -1. Remember, of course, that sine is the y-coordinate on the unit circle. So if we were just kind of sketch this out, here's my unit circle drawn perfectly, as you can tell, and it gets to -1 in this region. So that happens at an angle of, the first angle would be 3 pi over 2. So that's when it happens. But there's many others that it could happen at. Some of you are looking at this and you're saying, ooh, I don't see that one. Instead, I see this one. Wait, isn't this also an angle? And you're absolutely right. That's another angle that would work just fine. -pi over 2. Well, with these in mind, you could actually create an equation that would represent all of them, because if you start with 3 pi over 2 as kind of your base solution, which would be the only solution between 0 and 2 pi, then all you'd have to do is say, let me add on 2 pi times k. And k will represent any integer. So as I do this next problem, as I get to the next piece, I don't need a separate -pi over 2. That would be the solution to this when k is equal to -1. And when k is equal to 0, I'll get 3 pi over 2. And when k is equal to 1, I'll get the next value. So in our minds, just to kind of get a feel for this, if we're adding 2 pi, but we've got it over 2, it may be nice to kind of think, oh, that's the same as 3 pi over 2 plus, now this 2 pi would become 4 pi over 2 times k. Now what I've done is I've got a nice common denominator here. Again, this is another way to represent the exact same value. So this would help if you were trying to make a list of all of the possibilities. All of the possibilities would be, well, there's infinitely many going this direction, with negative pi over 2, then 3 pi over 2. Then if I add 4 pi over 2, which would be a k value of 1, that gets me to 7 pi over 2. And continuing on would get me to 11 pi over 2. And 15 pi over 2. And it goes on and on and on. Now to help you kind of see what's going to happen, these are the possible values for theta. Any one of these would represent a value for theta. In the end, we're going to want to solve for a value of x. So to help you visualize which one of these do we want, let's take a look at the graphs. For the graphs, what we're going to do is, I'm going to go up to y equals, I'm going to put in my equation, x squared plus 3x plus 3, and I'm going to make that a dark line, like we saw in the other videos. And then I'm going to enter some of these values that we came up with, like what we have below, which is 3 pi over 2, -pi over 2, 7 pi over 2, 11 pi over 2, and 15 pi over 2. I added many of these different values. And what I'm going to do is I'm going to graph this. I want to choose a window that makes sense. So if I do a zoom standard, here's what it's going to look like. There's my parabola. There's one of those possible values for theta. There's another value for theta. and the other values of theta aren't showing up. And the only reason is that my screen only goes up so high. So what I'm going to do is I'm going to change my window. So the x values are okay, but I'm going to change the y values to be from -5 up to, for this problem, maybe I'll go up to say 20. And I'm going to go ahead and count by 3s just so it's a little bit easier to see. And now I'm going to go ahead and hit graph, and let's see what that one looks like. And I'll put it on the large screen here too. What you're seeing, these bars are representing the different values of theta. So this value represents -π/2, and it doesn't even touch my parabola. So there's no reason to consider it as a solution. The next ones do touch, and you'll notice each one of them is going to touch twice. The value I'm looking for is the smallest positive value, which should be located right in this region. And if I wanted to find where those actually hit, I could calculate the intersection, which is number 5. And I could calculate the first curve, which is here. And then my second curve in this case, which is 3π/2. And my guess is that it looks like it's hitting right about here. And it tells me there's the value. There's the x-coordinate where they actually hit. So now I'm going to go ahead and clear this screen, get back to my main screen, and type in x. There's the x value. Well, how did they get that x value? We should be able to solve for it. So let's try some of the techniques we know how to solve for this. So I'm going to close this back down. We now can see from our graph that we're looking for the parabola to intersect positive 3π/2. That will produce the smallest x value. Notice there's a lot of x values that produce solutions here. Some are negative, some are positive. But what we're looking for is the smallest positive one, and that will occur when our parabola hits 3π/2. So what did we just find? We now know from kind of looking at a graph that this is the one we want. This value for theta will produce the smallest value that's positive for x in this solution. So let's go off to the side and solve this then. So now we've got, let me scroll down and give us a little bit more room. X squared plus 3x plus 3. I want to know when that equals 3π/2. Now again, when that equals 3π/2, sine of 3π/2 equals -1. So that's what I'm looking for. I'm looking for that value. So let's go back down here. Now I'll go about solving this. So now what I'm going to do is bring everything over to one side. So this 3π/2 now becomes minus 3π/2. And it's set equal to 0. Subtract it from both sides. Now, as you can see, what I've got here is the quadratic formula just lurking. The a value is 1. The b value is 3. And the c value is this entire thing, which is 3 minus 3π/2. So to solve for the real solution here, I would set this to x equals -b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 3 minus 3π/2, The whole thing is divided by 2a, which is 1. So now we can simplify this a little bit. X equals negative 3 plus or minus the square root of 9 minus 4 times 3, so minus 12, plus 4 times 3 divided by 2, 6 pi. Again, the whole thing is divided by 2. So giving a little bit more room, we'll finish this off. X is equal to negative 3 plus or minus the square root of 6 pi minus 3, the whole thing, divided by 2. Well, now we can go back and put this in our calculator. We've got two possible values then. So one of those possible values is x equals negative 3 plus the square root of 6 pi minus 3, the whole thing divided by 2. And the other possible value is, let me put this in here, or x equals negative 3 minus the square root of 6 pi minus 3 divided by 2. Now remember what we're looking for. We're looking for the smallest positive x value. So if we go back to our graph, we're finding two values. One of them is here and one of them is over here. The negative value means nothing to us. So over here, this negative value that we've just found, I know it's negative because it's negative 3 minus the square root of something, which is going to be non-negative. So this value is negative. So this entire component here is negative. So we don't want to use it. So instead we'll come back over here. This is our final solution. And to calculate it, let's put it into our calculator. So I'm going to put it in our calculator as negative 3 plus the square root of 6 pi minus 3 divided by 2. And take a look what we come up with as our final answer. 0.490575036. And if I check my value of x that I came up with earlier, that's the same value that I found on the graph. Now the one that we found here, the one that we found using this work, algebra, instead of the graphing calculator, is the exact value. The other is a decimal approximation of that. It's always good to have the exact value when possible. That way you might be able to simplify it or combine it with other pieces. And who knows, you might end up with a nice rational number later. But currently this is an irrational number, and it's approximately 0.490575036. So this piece turns out to be x is approximately, this is our decimal approximation, 49550375036. And here is our end result. So try another one like this, go back to your WebWork, practice another one, continue working on these, because what you'll notice is, from we started at the top, we started with a sine function. So even though there's something inside here, don't focus on it. Think about the sine function. When does it become negative 1? As you do that, you'll work through a little bit of algebra and be able to find the solution. All right, off you go.